So you finally made it to the end of geometry, and hopefully you're pretty close to passing, and this one last test is the only thing standing in your way. So let's get it done. It's only on 2 chapters, but it's going to be 25% of your grade. So knowing all your parts of your circle, make sure that you can identify what each one of these are. So make sure you pay attention to the symbol on top of it or out in front of it. Like this is an arc symbol. It's kind of drawn, hand drawn there, but it's still an arc. So arc BC is less than halfway, less than 180. So it will be a minor arc. Next, we have angle. Notice the angle. AEB. AEB is a certain type of angle we've studied. Where's the corner? At the center, so that's a central angle. Next, we have AH. And even though I just said AH, and still it put the arrows on both ends, so that means the whole line. I could have said ray AH or ray HA, it wouldn't matter. Or a segment even. All those are still even because it doesn't go inside, it just touches it at one point. That's a tangent line. Next, we have DC. Line DC is coming in the circle and going out. It's got an inside part, outside part. That's a secant. And then segment BE, that is a radius, okay, as opposed to DB would be a diameter. Make sure you know the difference. If you don't by now, you're probably in trouble. And arc ADC, ADC is exactly 180. So we had a minor arc earlier, but is that a major? No, because major has to be more than 180. That's exactly 180, so that's a semicircle. Okay, and there's a couple more just thrown in to see if you know what you're talking about. What about angle? Angle BDC. BDC. What kind of angle would that be? When the corner, it's on the edge, when the vertex is on the edge, then that is an inscribed angle. Okay, inscribed. And then I don't have any interior. I do kind of have, no, I don't have an exterior either. So I didn't have those on there, but we'll get to them. Alright, then you're going to be using the drawing to find certain measurements inside of the, or, you know, over here. So make sure you pay attention to what you're looking for. Angle JOL. So JOL, we're going to be looking for this angle. And then arc LK. L to K, that's that arc. And then LJM will be that arc. So we're going to be looking for a lot of little things. But let's start with what we know. When we go to our information up here, angle KOL is 30. So that needs to go up the side of that angle, KOL. And then remember, if that's a central angle, then it's going to be equal to its arc. And I also have 90 already on here, so this will be 90 out here. And then a couple other ways to find the other angles is good old standby, 180. Subtract from 180 and I'll get 150 right in here for LOJ or JOL. That's what we did, 150. And the arc that goes with it out here would be 150. And then the same thing with your 90, you could do 180 here, and so you'd have another 90 there. So try to find everything you can on the drawing first, and then you can go answer the questions. So now we want angle arc LK. This is an arc. Number 8 would be 30. And then arc LJM. Now be careful with it. LJM. to J to M. Alright, so add up those two parts and you'll get 240. Alright, we had one like number 10 on the Raiders of the Lost Ark. You need to put in your own numbers here. Angle E is 40, angle D is 60. Well, you could easily find angle F. That's a triangle, right? Triangles make 180, so F's going to be 80. Okay, 80. Oops, sliding off there. So then we got to find some arcs. Arc DE, and DE is right out here, DE. And so we need to stop and think, what angle opens up to that arc? Does 60-degree angle open up to that arc? That's the 60 right in there. No, it's not that one. And then let's look at the 80. Is the 80 opening up to that? Yeah. Okay, so now 80 goes with it, but what kind of angle is it? Is it at the center? No, it's on the edge, so that's inscribed. The angle is supposed to be half the arc. So what's going to happen is this 80 comes out here, it's getting bigger. So we're not taking half, we're actually doubling it, because we got the angles 80. 80 is half of what? 160. So you took times 2. And you'll get arc DE. Okay, and you could find the other ones the same way. Arc DF would have been 80, and arc EF would have been 120. And all together, they should add up to 360. Betcha. Okay, and then there's an easy one. This one used to be a little bit tougher, but I made it easy. Arc HG, we're only missing one piece. Add up all the ones you got. You get 270, so arc HG is 90. Subtract it from 360, all the ones you got. I think that's right. 200, 270, yeah. Alright, then find an angle X and find an angle A. That's your interior and exterior. Now they had a little bit more involved formulas. The angle of an interior was the arc plus the vertical arc all over 2. So we want to find angle X. What's its arc? X is opening up to 50. What's the vertical arc? 60. Vertical, remember vertical, it's going to make this big X right here. So the vertical arc will be 60. Add them up, divide by 2. You get 55. I could have made it tougher, but I didn't. Made it easy. Alright, next you have to find angle A. The formula for exterior is the big arc minus the little arc divided by 2. Alright, so I don't have my big arc. When I look at this angle A, there are 2 arcs. The 30 is one arc, the little arc, but the big arc we don't know yet. But what have we not really looked at? Look at that line going through O. The center is O. That line is called the diameter, and this makes this half worth 180. I got 30 and 70, so I need another 80 out here to make 180. So that's my big arc is 80. So 80 minus the little arc, 30, all divided by 2. Make sure you subtract first, and on the other one, make sure you add first. Get that top answer, and then divide by 2. Don't just take half of 30. If you put in the calculator 80 minus 30 divided by 2, you're going to get it wrong, because it's going to work that first instead of doing the top part first. So you should get 25. Alright, next, the second part, we have segments on circles. So these are 2 chords. When it's 2 chords that crisscross each other, all you got to do is get their products. So 5 times the 6, let's see, let's find like this. 5 and 6 are on one chord, and X and 4 are on this other chord, and they just multiply their individual pieces. 4 times X, 5 times 6. This makes 30. This is 4X. Divide it out. and x is going to be 7.5. So that piece will be 7.5 inches, or whatever. All right, now this is a secant, and this is a tangent. Now, a secant can be equal to a tangent, but not just the products. You got to do a little extra work. Secant is whole times the outside piece. Tangent piece gets squared. All right, so our tangent's easy. We got to square the 10. That's 100. The easiest way to do the secant, I think, is just to leave that W, the whole, as W. What's the outside piece? 8. So 8W going into 100, and you get, see if I can get my calculator to work. I know it's a decimal. Where are 12.5. So if the whole length is 12.5, think about that. That's one big long segment. You're saying it's 12.5. You got one piece of the segment that's 8. The other piece is y. Segment addition postulate one more time. And you get 4.5 for y. 4.5. They add up to 12.5. That's what we're talking about. This whole thing was 12.5. Subtract it and you get 4.5. Alright? Easy enough. Now, super easy. When there's two tangents meeting in a corner, they match. So, everywhere you see a corner, see if you've got a matching piece. Now, it only goes until it hits the circle. So, that's a piece that'll match that piece, but right now we don't have either one of those individuals. But look at this corner. I got 5. I'll have 5 right here in this corner right by it. I got 4. I'll have 4 right there. Now, those longer pieces, like the 13, that's saying both of these, the 5 plus something else makes 13. So that's going to make this other piece 8, and that'll make its other match on its corner right there, 8. 4 and something else makes 10. 6 goes right here. That'll be the 6. There's 4 stops at the point where it touches, and 6 will be out here, so 6 will match. So our Z that we're trying to find is 8 plus 6, 14. It's just the corner pieces that touch. Let me see if I can highlight them here for you. 6 will match 6. 4 will match 4. 5 matches 5. And then we found the rest of them by 8. We found the rest of them by segment addition. Okay, so notice how the corners, the pieces that meet at the corner, match. Alright, then we had, if you have parallel lines cutting through the circle, the arcs that they intercept will always be matching. So if that's W, this is going to be W as well. Now, W is not the answer, of course. I want a number. And what do we need to notice? What's happening right here? There's our friend, the diameter. So this half makes 180. I need 180, and I've got 130 up there at the top. That leaves me 50, but who's getting the 50? I got 2 W's. 2 W's will make the 50, so the W will be 25. Alright, now the shaded area. And this must not have transmitted to, copied very well, because what's supposed to be shaded doesn't look shaded, but this is all shaded up in here. Okay, we did these in class, yeah. Alright, all that's shaded, and then these little triangular parts that we've done before in the past, we've shaded those. That's the shaded. So, of course, shaded area is always outside minus the inside. I have a circle on number 5 on the outside. I have a circle on the inside. The formula for circle, pi times radius squared, pi times radius squared. And I think this one's going to be in terms of pi on this one in particular. So you don't have to put it in the calculator necessarily. All right, what you do need to be careful of is your radius, because that's what's going to make a difference. On the inside, you see that 2? That 2 stops right there. And so that part's 2. That's the inside, has a radius of 2. So that'll be pi times 2 squared. But the outside is not 4. Look at it close and think about it. There's 2 here, and then I got an extra 4 right here. I know it's not drawn the right size, but if I want the circle that's on the very outside, the center of that circle is still the same center I started at. So I got to go do all of it, not just the 4 that's out here. I need the whole thing. So that's 6 for that radius, and that's the main trick that people tend to miss there. All right, so this is 36 pi. Go ahead and square it, minus 4 pi. So your final answer will be 32 pi. And we're just going to leave it like that. That's the way the ACT does it. So we're going to leave it like that. All right, next, we're going to do that other one. Same thing, outside minus inside. And it's a square on the outside, circle on the inside. The square would be 15 times 15, base times height, 225. The circle would be another pi r squared. Where's the radius? We don't have a radius. We could find it. Remember, all the way across would match all the way across up here. 15, 15. So halfway will be 7.5. So 7.5 squared. And I think I just let you put this whole thing in the calculator. So 225 minus 50, what was it, right? 7.5 squared and pi. Don't forget pi. And you get 48.28 or 48.3 if you round it to a 10th decimal place. And you can always use 3.14 for the pi too if you want to. Alright, more shaded area. These showed up better, good. Alright, so, but these are not outside minus inside. This is the piece of pie, or in other words, a sector. And so the sector area is going to be the degree of your sector over 360 times pi times radius squared. And that'll be for both of these. This is just like a bigger piece of pie over here. So, what is my degree? I got 85, but that's not the shaded part. I need this part. Well, that's just an easy 180. Subtract 85, and I'm going to have 95 for my degree. 360. Pi times, is 22 the radius? What about if it's in the center? No. 22 is the diameter when they write it in the center like that. So the radius would be half of that, 11. Put the whole thing in the calculator. 95 divided by 360 times pi times 11 squared. 100.3. Okay. Alright, and then on the next one, same formula, just new numbers. Alright, what's the degree? It's not 60. 60 is not shaded. I want the shaded degree. So all of this, how many degrees? That's a quick check. The full circle's 360. Take off the 60, 300. So 300 is my degree over 360 times pi times 30 is the radius that time. And I think I got this right. 2356.2. We'll check it again and make sure. Pretty big because the radius is so big. Yep. There you go. That's the area of that one. Alright, now arc length, same idea. The arc length formula is going to be the degree over 360 times pi times diameter. Because pi and diameter, that's circumference. We just want to know the length of CDE, that is this way, okay? So I made it pretty easy for you. 210 is the degree, because that central angle will equal the arc, and over 360 times pi. But is 12 the diameter? No, 12 is the radius, so double it, 24. 210 360 times 24. 43.98. 43.98 would actually round off to 44. Even the tenths place, the 8 would make the 9 go up. 44.0 if you want to be happy about it. Okay. And then, same formula for the next one. Just be careful with your degrees. You have all FGH, all of that, and just like the other one, I need to take it away from 360, and I get 295. So 295 over 360 times pi times diameter 20. That's why you write your formula down, so that you'll be looking thinking, oh, is that really a diameter? No, that's radius, so I put it in there right. 51.48 or 51.5, rounded to the tenths place. Then we got to graph a couple and we're done. Alright, so plot the circle. Now, of course, on the test, I'm not going to make you plot it, but I am going to ask you, like, where's the center point going to be? So, where's the center going to be? Remember, if it's in the form of an equation of a circle, then your x and your y are showing you what your center is going to be. You just need to change the sign. So, instead of -6, it'll be 6, +6. Instead of +4, it'll be -4. So the center will be at +6, -4, right there. The radius is shown by doing something to this number. Radius squared is 16. I just want plain old radius, so I got to get rid of squared. Square root it gets rid of it, so you get 4. So this will be 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. And so your circle would be something like that. Okay? So now we're doing the backwards version. So you're going to say, where's the center? Well, you can just look at that and tell me that location, ordered pair. It's going back 5 and up 1. So -5, 1. What's the radius? Count it up. 1, 2, 3, 4 spaces. Alright, so when you plug that into your formula, which one of these is correct? So if you're not sure, that's where it's going to mess you up. What were you supposed to do? Change the signs. So -5 has to be positive, so can't be that one, can't be that one. Got to be either C or D. And then if you change the 1, it's going to be negative. So there we go, we got a negative. And then for the 4, you've got to square it. So that's it, answer D. And that should do it. Good luck.